The next topic is LTE Antennas and Identifiers. Now we are going to start with the introduction to antennas. As mobile devices are small in size, so the antennas must be of comparable size also. UE antenna configuration is as A node B sends a signal at a high speed. UE must receive signal at high speed also. So antenna of UE must be upgraded so that it can have maximum throughput values and bit rate. UE works on dual port configuration in which two ports are used to receive or transmit. Thickness of the antenna should be 1 cm or 0.5 cm, and width should be equivalent to 6 cm and length should be approximately equal to 12 cm. Two ports are orthogonal radiating elements to have pattern diversity so that they can provide more data rates. These ports have zero separation so that there will be size reduction. When both ports are excited, MIMO technology is used in that case. Port 1 is excited, which is transmitting and receiving, and port 2 is terminated. Third case is port 1 is excited, which is transmitting and receiving, and port 2 is open circuited, which is receiving but one at a time. Next is specific absorption rate. SAR is defined as the energy absorbed by the user body tissues should be less than certain values so that it can't damage the tissues. It limits the energy dissipation. Its units are watts per kg tissues. All the devices are manufactured by taking into account the energy dissipation concept so that radiations can't penetrate into the human body in large extent. Otherwise, the body cells or tissues get damaged. There are two standards of SAR, that is European and American. According to European standard, SAR should be less than 2 watt per kg tissue and use 10 gram cube localized peak. And according to American standard, SAR should be less than 1 watt per kg tissue and use 1 gram cube localized peak. So, localized peak here defines the amount of energy dissipated per tissue. Before manufacturing the device, we must take into concern the amount of energy dissipated, specifications like length, width, and height. Next is antenna selection parameters. Antenna is a deciding factor for beamforming and coverage areas. So, antenna selection parameters are: first is beam width or beam pattern. Every antenna forms its own beam. The area up to which the beam of antenna provides coverage at different angles is known as beam width. Second is bandwidth. In LTE, there are FDD and TDD modes and the antenna should follow the bandwidth criteria. Third is power handling capacity. Transmission of signal depends on the radiating power. Next is gain. In air interface, there are large number of losses, so gain is provided so that signal can boost up. Next two parameters are manufacturer and antenna should be cost effective. There are directional and omnidirectional antennas. Patch antennas are used because of its handling capacity and can be of any shape, which can be connected in both series and parallel modes. There are two parameters to adjust angles at which beam is formed. That is E theta equals to 0 to 90 degrees and E phi equals to 0 to 180 degrees. To have a beam in one particular direction, there must be given an appropriate values of theta and phi. Full beam is a combination of E theta and E phi. There are both the major beam and side lobes. MIMO technology requires agile antennas because these antennas can cross highly concentrated concrete walls. E node B provides data to multiple users, crossing all the hindrances in between. Next topic is introduction to identifiers. As we all know, identifiers are the identification numbers that are used to identify the user as well as the network. There are various identifiers such as MSISDN, that is Mobile Subscriber Integrated Services Digital Number, IMSI, that is International Mobile Subscriber Identity, N, that is Temporary Identification Number, GUTI, that is Globally Unique UE Temporary Identity, STIMSI, that is SAE, Temporary Mobile Subscriber Identity. IMEI, that is International Mobile Equipment Identity. Now we are going to first start with MSISDN. So it is the contact number which is user specific with specified country code. IMSI is used for security purposes. This number is secure, which is corresponding to MSISDN. Next is TIN. UE has context saved in its memory, and contains TIN parameters. So TIN parameter contains different GUTIs. Next is GUTI. It contains temporary identification of UE, which is unique globally. When UE wants to contact to the network, it will send GUTI, which is allocated to the user and to the eNode B. GUTI has address of MME, which helps to locate the particular MME in the core network. It is user identification according to MME, which has two categories, that is GUMMEI, which is known as Globally Unique Mobility Management Identifier, and MTIMSI, that is MME, Temporary Mobile Subscriber Identity. Whole GUTI is of 80 bits. GUMMEI composed of MCC, MNC, and MME group ID and MME code, whereas MCC is mobile country code, MNC is mobile network code, and MME group ID combined with MME code is MME ID. Next is some key points regarding the identifiers. When UE fallbacks from LTE to 3G network, then it will send MTIMSI to the core network to get access to the circuit switched network. STIMSI is used to locate the SGW in the core network, and IMEI is used to identify the UE by the LTE network. So this is all in this